Okay, today is 4.3. It's our last day to talk about reciprocals, and I'm starting the review process because tomorrow we need to do a full review, and then the next day, Thursday, is our test on basically reciprocals and graphing in general. What I'd like to start with is this equation right here, y equals x squared plus 3. And just a reminder, this is the rule for even, and if you had forgotten that, you should memorize it. And even functions have this kind of symmetry. And I'd like you to try to prove to me, using this formula, using this little proof here, if this equals that, then you have proven that they're even. Prove to me that that function is even. I'll pause for a second while I give that a shot. So we're back, and you should have stuck a negative x into this function, and you should have said y is equal to negative x squared plus 3. Y is, of course, synonymous with f of x. And then when you actually work this out, you realize, oh, squaring it will cause the negative to go away. Y equals x squared plus 3. This y, remember, like I said, is the same as f of x, right? The original was right here. The changed one was where we did f of negative x. And if this and this were the same, this rule right here, we would have proven that they were even. Is this truly the same as, when it's simplified, this? Yes, and therefore you've proven that they're even. Now, the way I'd like to have you show that is in a two-column proof format. So I want to give you another one now, and we're going to ask you to see if you can prove that this one is odd, and I'd like you to draw it just like I'm showing you right here. It's just a two-column proof is a really common math technique, something you should be used to. And I'd like to have you say y equals x to the third plus 2x. Tell me, is that odd or not? And you have to be able to prove it. And by the time you're done with this little statement, you'll have proof that it either is or isn't odd. All right, so if you're testing if these two are odd, first thing you got to do is stick in f of negative x. That look familiar? It's the same thing we did last time. So we stick in f of x. Actually, we're doing f of negative x. Will be empty spot cubed plus 2 empty spot. This is so important. Always start with the parentheses. They become even more important on the other side. Then I drop in a negative x, and I simplify it down. F of negative x becomes negative x cubed minus 2x. Now over on the other side, I have negative. Notice me putting parentheses in, because why? Because you know what almost everybody does? It's so sad, and they get it marked wrong. If you don't have those parentheses, do you get what they're going to do when they make it negative? They're going to stick a negative right there. You see what I mean? And how that's wrong? It doesn't work. You need a parenthesis so you can distribute the negative. Negative x cubed minus 2x. And now look, they are the same. And the kid who forgets to put the parentheses in won't think they are the same. All right, so they are the same. And we've proven that that this function was a what? An odd function. Okay, good. That's odd, even. What if I tested it for odd? It wasn't odd. I tested for even. It wasn't even. Then what? Then you just say neither. You're done. But you can't just say neither. You have to prove not odd and not even. If you're going to prove neither, you got to prove it's not the other two. All right, good enough on that. Do you remember me giving you a point like 2, or let's say negative 2 comma 8, and saying, what if I took the function and I did this to it? Do you remember? The new function, let's say call it g of x, is going to be all this. Do you remember changing a point and telling me where it landed? Would you please do that right now? So, hopefully you knew that the x part of this, the negative 2, goes with this. That's where x goes, right? Because if I go, this is kind of like this. G of x is like 2, and then I'll do it in red, f of x minus 4. That's where the f of x part is. That red part is like the f of x part. And this part specifically is the x part of it. All right, so that's why we put it in for this part only. So x minus 4 is negative 2. And then you just add 4 to both sides. X equals 2. Then I go to the y side. Here's y. Where does that go? And this is more confusing for people. The 8 goes in for all of this. See, that is where f of x is, right? So all of that then is f of x. All of that becomes an 8. And I figure out what I've got now. 2 times 8 is 16 minus 7. Did you get 9? Did you get a point then of 2 comma 9 is my new point? Raise your hand if you got that right. Okay, awesome. Now what did we really do? We took a function and we moved it. Let's talk about what all of those moves are. What if you have this? That was an absolute value shape, a V shape, and I moved the whole V where? I'd like you to tell me. There's 1, 2, 3, 4 things that happen, and I hope you remember the order that you should do these in. A hint, start on the inside. I'll pause for a second while you give that a shot. Okay, some words you should have used. Right 4. The whole function got shifted to the right 4, so the V shape went right 4. Why did I do that first? Because I believe starting on the inside is the most logical place to start, because when you're doing a complicated math problem, you always go to the inside parentheses, the parentheses that are inside the other parentheses. You always go to the inside. I can show you that in like 12 different cases on hard math problems. You got to start them on the inside. Now back to, once I'm done on the inside, I go to the outside. And I have to do them in the order of math, which is, please excuse my dear Aunt Sally. So parentheses are first. I already did them. They're already done on the inside there. There's no parentheses on the outside. So then it's exponents. There's no exponents. Then it's multiplies and divides. Aha. This comes next then. Of those two things, there's actually two things there. There's a reflect and there's a stretch. You do not have to do one before the other because really -2 is one thing. So I don't care if you stretch and then you flip, but I will say from honestly, it works for gymnastics and it works for math. That's if you stretch first, it's easier and then do your flip. Okay, because if you flip it and then you stretch it, it's more complicated because the thing's upside down now and you aren't as used to the shape looking that way. So it's easier to stretch before you flip. And I can't just say stretch, I have to say factor 2. Stretch factor 2. And what kind of stretch? Vertical or horizontal? And if you remember that it's vertical on the outside, that would be wise. Vertical on the outside and then goes with horizontal on the inside. Hi-vo, just like the Dwarfs song. Hi-vo, hi-vo, that one. Okay, number 3 is the stretch before you flip. And I should not use the word flip. I should use the word reflect. I don't know how tough we are going to be on not using the word flip. I have to check with my colleagues because I know somebody's going to say flip. But if you just say reflect, I know I can mark it right. Reflect over the which axis? I think it's smarter to say reflect which way? Vertically. Or vertical reflection. And the last thing is, you don't have to be complicated and say it's vertical shift up 7. You can just say up 7. And those are your 4 things in order that are happening in this function. Any questions on all that? Okay, so your homework for tonight, I haven't reviewed everything that you need to know. I've reviewed a bunch of it. But your homework for tonight is to practice those really tough ones. I want to do one with you before we start the homework. And it is, if you are still in this file with me, you can find it and it'll be a lot easier because you can just do it right on this picture. It's slide, can somebody tell me which slide number it is for you guys? 11. Find slide 11. If you are doing the reciprocal, which is, by the way, 1 over f of x, that's that whole thing. You remember that the asymptotes are key, right? Do you remember that, what is the other spots you want to look for? 1. Wherever the thing is 1 or, well, 0 we already had, that's the asymptotes. Okay, so there's asymptote here, asymptote here, asymptote here. All of those are asymptotes. Okay. Besides that, there were the spots where the graph is 1, because 1 over 1 is 1, and therefore those are spots where your new graph is going to touch the old graph. What was the last thing that I said was important and I haven't mentioned yet? Yes? Local mins and local maxes. Very good. So where is the local min? Right here. This is a local min. That spot's important. You want to do 1 over that spot. Remember, it's the y of that spot that's important. Now, that happens to be at -1, which is another important spot, which basically means it stays exactly where it is on my new shape. All right, so this is another local maximum. That spot will not stay exactly where it is because it's at -4, 3. And so its new point would be 1 over the y, right? The x stays the same. So here's my new point. -4, 1 over the y, 1/3. -4, 1/3 is like right there. So here's roughly my new graph. Oh, wait. I didn't hit 1. There we go. 1 and 1. This is roughly what this part of the graph should have looked like. Raise your hand if you agree with me, if that makes sense to you. Okay, good. I'll give you a minute to try to finish up the rest of this. Your homework, if you are already done with this whole thing, go to where the assignment says day 2, and we're going to do the first 3 pages. Pages in this case aren't that many problems on a page. It's only like 3 questions on a page. So it's, again, a fairly smallish assignment, very doable. Okay, for this part, this is the one spot that it would share at 1. Then where this gets really, really small and close to 0, this has to be really big, like infinity. So it goes like that. This spot, it would share with the original function because it's at a 1, and 1 over, or -1, and 1 over -1 is -1, so it stays there. And where this gets really small, this gets really big. So it goes something like that. And then this it'll share with the original. Now notice, this one doesn't go forever. So it doesn't have any values between 0 and 1. You better not actually graph anything in here then, because the red line isn't in there. So in this area, as this gets close to 0, this gets close to infinity. So it stops right there. That's the trickiest spot on the whole thing, I'd say. That spot stays the same as the original. And again, as this gets really small, this gets really big, stops again. Another tricky spot. This is a spot that's where y is 1. It's going to share that with the original. And it looks like that. This is going to share with the original. As this gets really small numbers, it's 1 over that, so that makes a really big number. And therefore, we go like that. Okay. Any questions with that? Mr. B. I'm going to call these sections 1, 2, 3, 4, 5, and 6. So now, or nope, this is 6 and this is 7. Okay. Okay, 1, 2, 3, 4, 5. This section right here, yes.
Why don't you also indicate -1?
Ooh, you caught me. I never took this part of the graph right here and did it, did I? Thank you. Good point. Okay, so on that part of the graph, let me finish. I just never noticed that one. This is a brutal. You'd never have one this hard on your test, but it would have elements like this. That spot has to stay reflected. Okay, And then as this gets really small, this gets really big. So I know for sure it's going to go like this. Now, I would, in general, as this thing gets bigger, the other one's going to get smaller. Is it going to keep going forever? No, because it doesn't have an arrow on the end of it. Now, how far? Well, you can actually take this point and find out where it goes. That point is at 3, -3. And I can just go do my little point thing and say, okay, what's its new point going to be? Kind of like this. Well, the new point, in this case, would be at 3, -1/3. So 3, -1/3 is right there, about. And therefore, I should end right there. Yes? Okay, section 1, 2, 3, 4. Okay, for section 4, I think I did it right. Are you referring to this part right here? The other red line. Oh, dang, I keep missing little pieces of line. Yes, I haven't done this yet. Thank you. Okay, so that's a spot where it's going to touch again. And then as this gets small, this gets big. So there. Asymptote line, getting closer to the asymptote, stops like that. Thank you. Whew. Find another mistake. Yes? I think you got me. Do you guys agree that it shouldn't go any further left? I think you're right. I think you're right. Now, some people would even not understand why does this thing, it doesn't have an arrow on this end, but it has an arrow on that end. Because this is getting close to 0, like little tiny numbers, like 1/100th. And then that's going to make numbers like 100. And as it gets infinitely close to 0, this goes towards infinity. Whew. Thank you. You did catch me. One last one. If anybody else raises their hand, I'm going to just have to jump off of something. So hopefully I'll just keep a small chair nearby. No, I told you there's nothing this bad. But elements like this could be in the test. Like maybe the test will only have something like this on it, and that's it, or whatever. It wouldn't be this bad. No. Nobody. Well, no, I shouldn't say that. Some of you guys are really exacting, careful people and would get it right, but we don't make anything that hard. Okay, so let's see actually homework. Your actual homework starts right here where it says day 2, and it has a disturbing image. Kind of comparable to the inside-out teddy bear. This is the upside-down face. But yet, the face isn't really upside down, is it? The face is right side up. And the hair is what's been done. And then the neck, of course. So anyway, these are just a question. Face. I think what the guy did is Googled inside-out faces, because these are inside-out functions. I know, disturbing. Feel free to cover them up with white boxes if they're going to be fuel for your nightmares. All right, we're doing only pages 1, 2, and 3 with the inside-out beaver, I think. I think it's a beaver. Anybody, unless somebody has a... It's not me. All right. So starting here, it's only 3 pages, and they're awfully easy. So just enjoy I've practiced this enough with you for the last 2 nights. I think you're going to be fine. Okay. That's all I got for the video for today.